All right, welcome to today's lesson on the programming process, where we're going to learn about how we approach planning to create a computer program. So the programming process is divided into 5 steps. The first is to define the problem, then we plan the solution, code the program, test the program, and then finally we document the program. That last step, the documenting the program, actually occurs through all of the previous steps in the entire process. So the first part is defining the program. The big questions we need to ask ourselves: what is the purpose of this program? Generally, what are we trying to do? What is the problem we're trying to solve by creating this program? Then we have to figure out what kind of inputs we're going to need. What information are we going to need to use from the user in order to make our program function properly? Then we look at the outputs, so what information is going to be displayed to the user at the end of the program or during the program's running. And finally, any formulas or algorithms we're going to have in order to be able to solve the problem. So how are we going to get from that input to that output? Are there some sorting that needs to happen, like arranging things in alphabetical order? Is there some mathematical formulas we need to do? All that kind of stuff. Once we have a general idea of what we're trying to do and how we're going to do it, then we need to go into more detail into the planning of the solution itself. So to do that, we use a couple of design tools. The first tool we could use is what's called a flowchart, where we have a visual representation of the flow of the program. It's a little more generalized, using arrows and squares and circles and parallelograms and stuff. We covered that last year in the grade 10 course. This year we're going to be working with pseudocode, which is plain basic broken English. It has some sort of a logic structure, so we can see logically the steps that we're going to follow in order, but there's no command keywords. There's no Java specific or Python specific terms in there, so that this structure could then be turned into any programming language. Once you've sort of made that flow out, we then go into desk checking, where you personally do a code design walkthrough. You walk step by step through the code, sort of predicting what's going to happen each time to make sure logically it makes sense. You can then give that code to a peer review, where they sort of, again, go through the same sort of process of stepping through the code one step at a time, making sure logically it makes sense before we invest the time into actually writing out the code. Pseudocode itself, if we look at it a little more closely, it can be converted into any programming language. Again, there should be no language-specific keywords in there that are Java, C, Python specific terms. An example of what this might look like: we need to write a program that inputs a set of numbers and outputs their sum. So we'd say input number 1, input number 2. These would be variables where we're storing that data. Sum is going to be equal to number 1 plus number 2, and then the output, the sum. Once we have our pseudocode in place, we can then start coding the program. And this is where you're translating that algorithm or process into a formal programming language. Obviously, there are a number of different languages you could use. We are going to be using Java in this course. Once you've written your code, you then have to test the program. So the first type of testing is the compiler itself. This is a program inside your computer that's going to translate the source code that you've written in Java into binary code or zeros and ones. That's how it works in Java specifically. That process, while it's happening, the compiler itself is going to look for syntax errors or errors in the way that the code is written. So for example, something is spelled incorrectly, or is missing a semicolon, or is not indented properly, that kind of stuff. Debugging is the process that you use to test your program yourself. So once it's compiled, you run it, and you run the program over and over for a variety of different types of input or test situations. This is where you're looking for logic errors. You're looking to see if I do 1 plus 1 equals 4, right, instead of it being equal to 2. That tells me that I've done something wrong in there. I need to go back and fix the code. Through all of those steps, you should be documenting the program itself. You're generating material every single step of the way through that process. So in the beginning of defining the problem, you're going to be doing problem definitions and a program plan. While you're writing the code, you're going to be commenting the code itself inside the code to other programmers. You're going to be commenting out or documenting all the testing procedures you did. You'll be making help menus for the end user, a user's manual, all that kind of stuff. So that's it. That's all we have time for today. We'll talk to you in class tomorrow, where we can practice what we've learned.